Have you ever really stopped to think about what your mind, your inner world, your conscious experience is actually for? We tend to think of it as this grand, ultimate achievement of evolution. But what if its real job is something way more basic? What if your mind is essentially a high-tech security system, a bodyguard for the only thing evolution really cares about, your genes?
All right, let's dive into this idea because it's a big one. We're going to dig into the actual biological hardware that suggests our inner world, our subjective point of view, didn't just pop into existence. Nope, it was forged for a very, very specific purpose, to protect the body.
So that's the big question we're tackling in this explainer. We're going to investigate the theory that the mind itself evolved as this incredibly elaborate protective mechanism, a way to navigate a really dangerous world, keep the body in one piece, and in doing that, make sure the genetic code it's carrying gets passed on.
Okay, so to really get why this bodyguard was even needed, we've got to rewind the clock. Way, way back. Back to a time when our very distant ancestors did something revolutionary. They started to really move.
So, what you're looking at here is a peek into life over 500 million years ago. For the first time, you have complex animals that aren't just stuck in one place. They're exploring. But, with great power comes great problems. This amazing new ability, mobility, it created a huge new headache.
You see, as animals started really moving around during the Cambrian period, the world suddenly became, well, a total mess. Every single move they made created a flood of sensory information. Suddenly, their senses were just swimming in chaos.
And there's actually a technical name for this problem. It's called reefference. It's all the sensory feedback you get just from your own actions. Think about how the world blurs and rushes past when you just turn your head quickly. That's it. That's reefference. Neuroscientist Bjorn Merker even called these the liabilities of mobility. Every move you make bombards your senses with signals you created.
So it all boils down to this one absolutely critical question that every moving creature has to solve second by second just to stay alive. Did that thing happen to me, or did I do that? Telling the difference between an incoming threat and just the normal result of your own movement, well, it's literally life or death.
So how in the world did evolution solve this massive problem of self-made sensory noise? Well, the solution is pretty ingenious, and it's right here that we see the first little spark of what you might call a self.
This quote from Peter Godfrey-Smith just hits the nail on the head. Imagine you're a banded shrimp cruising around a reef. Your long feelers are constantly bumping into stuff. To survive, you absolutely have to know the difference between bumping into a rock yourself and the touch of a predator that's about to eat you.
So the solution that evolution came up with was brilliant. It developed these internal feedback loops, often called efference copies. It's the biological fix for that reafference problem. Basically, when the brain sends a command to, say, move a leg, it also sends a little copy of that command, a heads-up, over to its sensory systems. This copy is basically a prediction of what that movement is going to feel like. And the result is just so clever. The brain can now take the total sensory information it's getting and subtract the predictable feelings it caused itself. This is exactly why you can't tickle yourself. Your brain predicts the sensation from your own fingers and just cancels it out. What's left over is the surprising, unpredictable stuff, the "that was done to me" column. That's the signal that means pay attention. This ability to track the line between self and other is the very first, most basic registration of a self.
But, this pretty simple bit of biological hardware, it didn't just stop at telling me from not me. It became the foundation for something way more complex, something much more powerful that would eventually become what we call a mind.
And what's so wild is that this wasn't some one-off fluke. After the basic nervous system showed up, you see complex behavior and the tools to manage it popping up independently in at least 3 different major groups. You've got the arthropods, like insects and crabs, the mollusks, like octopuses, and of course the vertebrates, which is us. It's almost like each of these groups took that basic self-monitoring tech and used it to build a much more advanced tool, a kind of internal model or a predictive simulation of the world, with the self as a character, an active participant, right there inside of it.
And this isn't just some static map, It's a living, breathing workspace in the brain. It's constantly pulling in information from all the different senses, linking it up with memories of what happened before, weighing different goals against each other, and then knitting it all together into one single unified perspective, a point of view from which to act.
Okay, so let's see this whole internal model in action. How does this point of view actually work as the ultimate survival machine?
Because we're not just talking about simple reflexes anymore, we're talking about making really complex life-or-death choices.
There's this fantastic experiment by Robert Elwood's group on hermit crabs, and it just shows this process perfectly. They didn't just test a simple reflex. They tested the crab's ability to make a calculated trade-off. So, a crab gets a little shock inside its shell. Now, a simple reflex would be to just bolt immediately, right? But that is not what happens. Instead, the crab assesses the quality of its current home. A really good, protective shell is worth putting up with more pain for. The decision to leave is a trade-off, where it's balancing the cost of the shock against the value of its shell. This is high-level, integrated decision-making right there in a crab.
Over millions of years of evolution, this is the kind of process that got more and more sophisticated. What started out as just a hardwired, implicit instinct, like some ancient creature running from a shadow just because its ancestors who did that survived, eventually became something much more explicit. The internal model could now hold the abstract idea, shadows in this situation probably mean danger.
And this quote right here, this is the key. So how does this internal model get the body to actually do anything? The answer is feelings. Things like pain and pleasure are basically the brain's shortcut for bad for survival and good for survival. The organism doesn't have to sit there and calculate the long-term genetic benefit of eating a piece of fruit. It just has to follow a simple built-in rule. Seek out pleasure and run from pain.
So when you put it all together, the evidence really points to one powerful conclusion. This entire incredible cognitive toolkit that we call the mind was forged by natural selection for one main reason: to solve the complex problem of keeping a moving body safe and sound, and in doing so, protecting the precious genes it's carrying.
Which leaves us with one last kind of mind-bending thought. This whole elaborate system, our consciousness, it really does look like a biological tool for survival. But unlike any other tool, this one developed a point of view. It became aware of itself. And so the real question is, what happens when a tool that was designed just to protect something wakes up and starts asking why?